Hello friends, very good morning. In today's video, we are going to learn how to draw the projections of a circular lamina of a given diameter. Friends, let us see the question for today's video. A circular lamina of diameter 50 mm resting on HP on a point of its circumference appears as an ellipse with major axis 50 mm and minor axis 30 mm. Draw its projections when the diameter through the point on which it rests is inclined at 30 degrees to VP. Obtain the inclination of the surface of the lamina with HP. That is, we have to find out what is called theta. What is the inclination of the surface? Friends, here, the moment you have a problem on this lamina, we have to analyze, first of all, what is the type of lamina. That is the first part. It is a circular lamina, which has got a circular periphery and it has no edges or corners, as we have in case of other lamina like pentagonal lamina, triangular lamina, square, rectangular, etc. Friends, here, after knowing what the type of lamina is, you will have to just find out where the lamina is resting. So that is very important. There is a second part in the analysis. He says it is resting on a point of its circumference on HP. So this is a clear indication that the surface of the lamina has to be placed on HP. So I have to place the lamina on HP since one of the point on the periphery of this circular lamina is on HP. So and obtain what is the top view and what is the front view. Friends, here when the lamina is placed on HP, in the top view, you will be able to see the true shape of the lamina. That is a circle of the given diameter 50 millimeter. And in the front view, you see it as a line. The length of that line will be equal to the diameter of the circle. So let us complete this first position of the lamina when it is placed on HP on its surface. So friends, I have written the top view of the lamina. It's a circle, and let us obtain what is the front view corresponding to this top view. Friends, if you project lines from here, you will get on this xy a line of length equal to m, and that m is equal to 50 millimeter. So I will call this as m, which is equal to 50 mm. So let us name these corners like this. A, this is C, this is E, this is G. Only I have shown 4 points to start with. And let's see how to get the corresponding points in the front view. So this is going to be A dash, this is E dash, G and C coincide here. So this is going to be G dash, comma C dash, or C dash, comma G dash. So to start with, I have shown only 4 points on the periphery of the circle. Friends, he says the lamina while resting on its surface on HP, and when it is slowly rotated on one of the points, say A, that is, it was like this and it is going to rest like this. So what happens? When the surface is on HP, you see it as a circle. When it's slightly made to incline to HP, there is, it keeps on becoming an ellipse. And he has given a particular dimension, namely the major axis 50 mm and minor axis 30 mm. So when you just lift it, keeping A on HP like this, for a particular position of this theta, the angle made by the surface of the lamina with HP, you are going to get an ellipse. So friends, what I do, adjacent to this figure, that is a top view of the figure, I am going to construct what is called a box in which I am going to accommodate the top view of the ellipse, that is 50 by 30. Friends, you remember this dimension 50 or 550, we say, 5 indicating the diameter of the circle, and this remains the same. So I will just project lines from here and vertical line from here. So in this box having dimension 30 mm by 50 mm, I should be able to write an ellipse. So this point is A, this is E, this is point B, sorry, C, and this is G. So I should have an ellipse here for the dimension of 50 by 30 rectangle here. So I have to enclose or create or draw an ellipse in this. Friends, you know, this circular lamina has no edges or corners, and to get the projections of this, whatever the circle you have got here in the top view, that has to be divided into minimum 8 number of equal parts, so that those parts or the points can be taken as the corners on the periphery or points on the periphery. Friends, let's see here. So within this I should get the ellipse. So here in the first position I am going to draw lines at an angle of 45 degrees to the horizontal. So this is 45 to the horizontal. So the whole circle gets divided equally into 8 equal parts, and the angle between any of these two radii will be equal to 45 degree. So friends, let us complete this marking. We'll call this as B, C, this is D, E, F, G and H. So these are the points on the periphery of the circle, which is divided into 8 equal parts. So let me transfer those points to the front view. H and B will fall on this. So I will call it as H comma B. And here you will have CG already marked. D and F come together. So I will mark it as D dash comma F dash. So friends, finally the lamina is resting on HP. The front view is a line having length M. That is equal to the diameter. Now friends, I am going to just transfer all these points. So before that, let us find out what is the angle made by the surface. Friends, the position of this point is fixed. It has to be on HP. I will call it as A dash. A dash is fixed. Now friends, in all the problems on lamina or on solids, the figure, the front view you obtain here in the first position and that in the second position will be same. That means it will have the same dimension excepting for the orientation with XY. Friends, I have marked this and E should fall on this. So I will write a vertical line through this, a vertical line through E. Friends, we have got A dash, E dash, which is equal to 50 mm. I take A dash as the center and radius equal to 50 millimeter. I strike an arc and get that point. That end point will be E. So this is E dash. Friends, then you can mark the other points like C and G, C dash, G dash. Then on this, whatever the points you got to be marked there. And remember friends, this is again equal to 50 mm because this diameter length remains the same, 50 mm. After A, you got B and H. I will call this as B dash comma H dash. Then we have got C and F. sorry, D and F, D comma F. So friends, let us locate all these 8 points here onto this. So we will have A, then B and H will fall on this. How to get B and H? A horizontal line from B, a vertical line from B. The points where those two intersects is going to be point B. Similarly, you are going to get H here. Exactly on the other side, when you draw vertical from here, you will get, this is the other point. So here you get a point, here a point, again on the extension of this, you will get a point. Friends, you are going to get 8 points. A, this is point B, this is C, this is A, B, C is here, D, E, F, G and H. These are the 8 points on the periphery. And friends, since the ellipse has no edges, whatever the points you get in the top view has to be joined by a continuous curve, smooth curve. So I will just obtain this curve like this. So this is the top view of the lamina when the surface is making an angle theta with HP, and it is asked in the question what angle the surface of the lamina is making with the HP. So the inclination of the surface of this lamina with the HP can be measured using a protractor. That is this part of the question. Now friends, the lamina is resting on point A point on the circumference of the circle, the other end is E. And here you have got A and E. So this is the corresponding view in the top. That is a top view. What does he say? Draw its projections when the diameter through the point on which it rests. It is resting on A dash. The corresponding diameter is AE. That AE has now become parallel to VP. He says it has to be at an angle of 30 degrees to VP. So friends, what is to be done now? Whatever the view you have got here, the top view, has to be reproduced or redrawn such that AE, which is parallel to VP, this AE is parallel to VP, but that should be at an angle of 30 degrees to VP. So friends, I am going to draw a line here at any point on this XY line, say from this point, and friends, on this the edge AE should lie. He says the diameter is inclined, and there is a very important concept you should see here, friends. The original length of AE was 50 mm. Now the length is reduced. In the top view, it was 50, now it is reduced. And in the question he says, the shorter edge or the minor axis of the ellipse is at an angle of 30 degrees to VP. So friends, and if you observe the length of this, there is a reduction in the length. So whenever they say that the axis is inclined, and if you find there is shortage of length or reduction in the length of that particular axis or line or an edge, then friends, you will have to take the locus of that point and then obtain the corresponding top view. So how it is done, friend? So I will take some point this A at random. I will mark the true length of that line, that is AE, which is equal to 50 millimeter. So this is point E. That is A is the original length of that. Then friends, for this is 50, this is 50, this is also 50. Now this A, now we have to take the locus. What do we do? Through this corner E or this point E, you draw a horizontal line. So I am drawing a horizontal line through the end E. Yeah, I am going to fix it here. Next friend, this AE is the true length, that is 50 mm. I have marked here. But finally, this is the reduced length. I take this width, that is 30 millimeter, the minor axis as the radius, and strike an arc. Friend, so this will become E, the final value of E. So friends, on this line E, that is AE, you have to complete this box AE. So how we are going to construct that box? Friends, I can write a perpendicular through this, a perpendicular from here, perpendicular from here, and obtain that box. That is this rectangular box. So friends, it is easy to obtain the rectangular box because we know the height, we know the area. This is going to be 50 and the other dimension is going to be 30. So we have reproduced that box. So on this AE, which is shown here, you have to locate all other points. So perpendicular to AE, you have CG. So I will have the point here. This is AE, this is C, this is G. Friends, similarly, you have to locate all these points. For example, if you want to locate H, that is at this corner, nearer to that A, you have to get that point H. So, whatever the distance, these lines you have got, you can mark them here at the same distance. Obtain all other points. So friends, this is going to be B, C, this is D, E, F, G, and this is going to be H. Friends, from all this, whatever the figure you have got here, if you call it as figure number 2, this is written here as figure number 3. On these two ellipses you get here in the box, or these two figures are exactly identical. So friends, I am going to join all these points by a smooth continuous curve. So this is another ellipse. So these two ellipses are same. They have the same dimension. Friend, we have got the final top view of the lamina. From this final top view, we should arrive or draw the front view of that lamina. So friends, let us locate the points. There are 8 points, A to H. Let us locate one by one and see how we get the figure. So now I should get A. A dash is on XY. Horizontal from A dash, vertical from here. They meet at this point. I will call this as point A. Similarly, E I will take. E. E is here. So vertical from E, horizontal from E dash. The point of intersection will give you E dash. This point is A dash. So A dash, E dash you have got. Next, let us obtain C and G. That C and G will come exactly in between these two lines, C and G. Where is C? This is C. Write a vertical line from C, a horizontal line from here. They meet at this point. We will call it as C dash. Then opposite to C is G. G is here. Vertical line from G, horizontal line from G dash. They meet at this point. This point is G dash. So you got A dash, G dash, E dash, C dash. 4 points you got. You have to get the other points. Let's move on to the point H. Vertical line from H, horizontal line from H dash. The point of intersection will give you the point H dash. So I'll mark it as H dash here. Then on the same line we have got B dash, vertical line from B, horizontal line from B dash. They meet somewhere here. So this is point B dash, A dash, B dash, C dash, G you have got. Then D and F will fall on this, follow the same procedure, obtain the point D and F. This is D. So vertical from D, horizontal from D dash, the point of intersection will give you the point D dash. So you got A dash, B dash, C dash, D dash, E dash. Then I should get F, horizontal from F, vertical from this point F, they meet somewhere here. So that is point F dash. Friends, we have got all the eight points on the periphery of this ellipse. Let's obtain the complete front view by joining all the points so obtained by a continuous smooth curve. Friends, this is how we get the final end view, the front view of the ellipse or the circle. So friends, you can see here, we have completed the solution for this question. Here you can see friends, the lamina is making an angle with HP that we have found out. It is resting on A dash. A dash is a point on XY that is resting on a point of its base circumference, and the other end is E. So friends, we have the complete solution, and this is how we obtain the complete projection of the circular lamina. Friends, I hope you are convinced with the presentation I have made on this lamina, and if you are happy with the presentation I have made, please subscribe to my channel. Share the information with all your friends. Have a wonderful day. Thank you.